Okay, Assalamualaikum and good day. In this video, we will look at one of the example from final examination, paper January 2018. So, we need to consider the differential equation x y double prime, okay, plus 2y prime minus y equal to 0. And first, show that the point x equal to 0 is a regular singular point. Okay, which means here we need to show that x equal to 0 is a regular singular point. And then show that the roots of the initial equations are -1 and 0. And lastly, obtain the two linearly independent solutions near x equal to 0 up to the term x power of 2. Okay. This automatically, you know that in this case, 3, okay. Why? Because both initial roots are integers. Okay. There is no fraction there. Okay, the first step, as usual, you need to prove that is a regular singular point. You need to determine first what is Px. Px is equal to x, which means P0 is equal to 0, which means x is a singular point. Next, we check for the first limit test. We have limit x approaches 0. Here is x. Why? Because x minus 0. 2 over x, because it is actually qx over px. Okay, we have 2 over x. X can be cancelled out. That's why we only have the value of 2. And here, limit x approaches 0, x squared, because x minus 0 squared, -1 over x, because of we have rx over px. And here, simplifying and substitute the value of 0, we have it is equal to 0. Since both limit exist, therefore, x equal to 0 is a regular singular point. Okay, next, for B. We need to prove the initial roots, right? So, we have two ways to prove it. The first alternative would be, from the above solution in A, we have the value of A equal to 2 and B equal to 0. That means the first answer for the limit would be the value of A, and then the second test would be the value of B. Okay, so here the initial equation formula is given as r minus 1 plus ar plus b equal to 0. Okay, so here r squared minus r plus 2r plus 0 equal to 0. Okay, simplifying until here, you will have r1 equal to -1 and r2 equal to 0. So it is shown. Okay, remember again, the small value of r would be our r1. Okay, small value is r1. Okay, next, for the second alternative would be, that means we start from scratch. Okay, so we let y equal to summation of n equal to 0 to infinity a n x power of n plus r. Y prime is differentiate y with respect to x. Y double prime is differentiate y prime with respect to x. Okay, we have this y prime and y double prime. Substitute those three in the given DE, such as this. Okay, and then we need to expand the equation. Okay, we need to expand the equation. And here we have x multiply with x plus n plus r minus 2 and plus r minus 1. Okay, it's only this one that we need to expand. So the next thing is equate to the smallest power, x power of n plus r minus 1. Since here, as you can see, it is n plus r minus 1, n plus r minus 1. There's only this, the last term that we need to change to x power of n plus r minus 1, which means an would be an minus 1. And here, our summation would start at n equal to 1. For the first and second term, just rewrite them. Okay, as usual, initial equation. Okay, initial equation. Here we have r times r minus 1 plus 2r a not equal to 0. Why? We just take note the first and the second term. Just substitute the value of n equal to 0 in the first and the second term. We will have this equation. Okay, r squared minus r plus 2r equal to 0. Since a not does not equal to 0. Therefore, we have here R1 equal to -1 and R2 equal to 0, the same as the first alternative, the first way to show it. We have shown here that both value of initial roots are -1 and 0. Okay, it's important for you to factorize here, okay? I really need you to factorize here because this will help you to do your recurrence relation. Okay. Next, recurrence relation. We have recurrence relation for when n is greater than or equal to 1. So here it is n plus r plus 1. Why? Because in the above initial equation, we have the hint here. The factorized is actually r times r plus 1. So, as I have mentioned before, just substitute n plus r at the place of r. Okay, so r will be n plus r plus 1 will be substitute as n plus r plus 1. Okay, for an only, okay, minus, okay, the last part before we have here is what? Minus summation n from 1 infinity a minus 1, right? So, it is my negative a n minus 1. Okay, simplifying, we have this as our an. Okay. Next, you need to substitute the small value of r in the recurrent relation, which is r equal to -1. Remember, -1 is smaller than 0. Okay. So, an is equal to 1 over n minus 1 times n, an minus 1. So, when n equal to 1, we have a1 equal to, okay, we have 1 over 0 times 1, a0, which is infinity. Automatically, it is case 3b. Okay, when it is case 3b, we need to let a new arbitrary constant, which is b0. b0 is equal to a0 in bracket r minus 1. Okay, we have another bracket here. Because b0 is actually a0 r1, sorry, r minus r1. Okay, therefore we have b0 equal to a0 r plus 1. Okay, so use the recurrence relation, the earlier one, an equal to 1 over n plus r plus 1, an minus 1. So here we have when n equal to 1, a1 is equal to 1 over 1 plus r over 2 plus r a0. a0 is b0 r plus 1. Substitute, okay? And hence we have 1 over 2r b0 as our a1. Why? Because 1 plus r can be cancelled out with r plus 1. Okay. Next one, when n equal to 2, we have a2 equal to 1 over 2 plus r times 3 plus r, a1. And substitute a1 with a1 that we have obtained earlier, and hence we have a2 equal to 1 over 2 plus r squared 3 plus r b0. Okay, as you can see here, I continue to find the coefficient a3. The reason behind it because, as you can see here, when we factorize, actually SR is outside, right? So for this question, we have x power of -1, and we need to find the solution up to the term x power of 2. That means, let's say, if we expand x minus 1, multiply with all these terms here, that means when we multiply x minus 1 with x, we only get constant, right? Because x minus 1 times x is equal to x power of 0, which is constant. Okay, x minus 1 multiply with x power of 2, we only have until x. That's why we need to add another one. We need to find a3, because a3 x power of 3 plus until infinite. So x minus 1 times x power of 3 will be x power of 2. Okay, that's why I find the value for a3. So a3 is equal to this. Okay, next we have y equal to as such given here. So factorize. Yang paling cepat, since you know that every a has b0, that's why substitute b0 outside. Okay, here y equal to s power of r b0 r plus 1. because A naught is B naught R plus 1. So R plus 1. And then here factorize, we have 1 over 2 plus R, and it goes on until x power of 3. Okay. And then next, y1 is when we substitute the value of R equal to negative 1. So here, just do a quick calculation. Chongak, okay. R plus 1 is negative 1 plus 1, 0. Negative 2 minus 1 is 1, okay. And here 3 minus 1 is 2. Okay, simple calculation, quick calculation. You don't have to show your substitution, okay. And hence we have here y1 equal to b naught, open the bracket, 1 plus 1 over 2x plus 1 over 12x squared. Okay, why? Because I multiply x minus 1 is x power of 2, and also x power of 3. Okay. Okay, the next for y2. For y2, we need to find this first. Del y over del r. That means it will be y ln x plus b naught x power of r. Open the bracket. Okay, r plus 1 earlier. Okay, let me put it. Okay, it's much better this way. So r plus 1 here, differentiate, we will have 1. Okay, 1 plus 2r, differentiate, it will be, as I mentioned before, rewrite the function. 1 over 2 plus r, open the bracket. What is the power for the factor? This one, it will be 1. That's why 1. 1 over factor, 1 over 2 plus r. Since 2 plus r is in the denominator, so it will be negative here. Okay, x plus this one too. Rewrite. Okay, rewrite and then open the bracket. Okay, for the first factor, we have 2 plus r power of 2. That means negative 2 because it is in the denominator. So negative 2 power over factor. And then 3 plus r also in the denominator. So negative power is 1 over the factor itself, 3 plus r x squared. And then the same goes here for x power of 3. Okay. So y2 is del y del r of when r is equal to negative 1. So y1, okay, y1 ln x plus b naught x power of negative 1. So just do a quick calculation as we did earlier. Okay, chongak. And simplifying, y2 would be y1 ln x plus b naught x power of negative 1 minus 1 minus 5 over 4x minus 5 over 80 x squared plus until infinity. Don't worry, x minus 1 is also valid here, okay, because it is case 3. Okay, thank you class. Assalamualaikum.